talking about my technical biography, a blend between physics and engineering of small vehicle systems. So first and foremost, I speak about my origin. I came from Nigeria, a country in the West African sub-region. So basically, our economy as a country is based on oil production, slight manufacturing, and agriculture. Then, as a scientist, my scientific life has been influenced by the impact and influence of these scientists who I now take as my role model. The first is Philippe Emeagwali, a Nigerian who contributed to the development of the supercomputer in the 80s. Then the German rocket scientist uh, von Braun, a physicist like me too. Then the MIT professor Norbert Wiener, the founder of cybernetics, and the inventor of the microprocessor, Ted Hoff, which I end up studying. So I speak briefly about my educational escapade. Um, I did my primary school, my bachelor's, and the master's in Nigeria. So one thing unique about my education was that every school I've attended in the last um, 15 years, I always build a project and I leave it in the school and it becomes a form of legacy for me. So like in my secondary school, I developed a battery powered model vehicle, which you can see right now. And we won a competition, a science fair competition with it in 2008. Then in my physics bachelor's thesis, I built um, a locomotive vehicle to demonstrate electronic control of a mobility system. So which now stays in the school lab as a form of a museum or an artifact. So in my master's, my last master's in Nigeria, which was in engineering, when I crossed discipline, I developed an internet vehicle as my thesis. So you can see the picture of it here. So that's all about my education. So I speak briefly about my work experience. So upon my arrival in Germany last year, I got employed with the German Research Center for Artificial Intelligence in Bremen, where I worked for 6 months as a research assistant before coming here. So this gave me a first-hand experience into the German robotics and automation technology. So um, while I was in Nigeria, I was the HOD of robotics and drone technology at International College of Aeronautics, Lagos, Nigeria. So I built experiences on how to teach. How to teach students by demonstrating to them, by proving the concepts, and showing them how this actually works. And this style of teaching made me influence a new regime of students who believes in the practicality of science and technology. So I'm going to speak on my past projects in Nigeria, what I do every day, even though I'm being paid or I'm not being paid before coming here. So this was my former lab in Nigeria, in the school where I was teaching robotics. So I headed this laboratory. Then in the course of these works and in course of my personal development as a person, I was able to develop a number of devices which I'll be reviewing shortly. So the last work I did in Nigeria before coming here was the aforementioned internet vehicle. So the hypothesis was, how do we control machineries from the internet? Though I know it's not a new field of research, but in my country, it's something that um, it's a big thing in my country because I came from a society that's not that exposed to technology. So I developed an internet vehicle uh, um, to monitor remote locations in real time. So this is to show how to extend internet connectivity to standard device beyond the ones we are used to. I think we call that in this current um, industrial revolution, Internet of Things. So I was able to prove how we can control machineries anywhere on Earth using the internet. So these are some of the technical details about the vehicle system. You can see the arrangement of the gear for driving. So the steering system, which is based on the principle of servo mechanism, and the motor controller. Then this is a feedback loop that controls the motor servo. Then this is the a block diagram of the model of what I was trying to implement. Like we have an operator in a far location. Then he uses the internet to control a machinery that is embedded with the computer system. Then these are some of the analysis we did to check how, we call it latency, to check how efficient the control signaling is. Like, do we have delay in the relay of control signals between the operator and the vehicle system? And we got some impressive results because the signals came at real time within our technical limits. So this is the vehicle system here, which was published in 2019 in Elsevier journal called The Internet of Things. Then I also did other projects in Nigeria. The last one I did was a photonic device that is based on the principle of light spectrometry, light spectrometer. So we used it to measure the level of red blood cell in the body, that's hemoglobin level, concentration in the body. And we compared it to the manual method that had been applied in hospital, and we got very good results. So, and we try to show that yes, this device can be commercialized into a product that can be sold to make medical diagnosis faster and more efficient. So this is a robotic arm I developed in 2018 to prove a concept as a teaching device. Then this is a UAV I built in 2017. Then this was a toy car I built in 2014 to teach my students physics. So currently in Germany, I have my small laboratory where I live currently. So I use my study table to do some personal projects. So these are some of the projects I've done in recent time. Like this is a quadrupedal wheel robot I showed before this presentation. Then this is a drone I built last week. So it's actually meant to collect agricultural data. Then this is my programming table where I program my electronics and give them the software that performs the various control functions. Then this is the one I showed of recent, the quadrupedal wheel robot system. It's a multi-terrain system for navigating instruments, sensors over rough topography. So I came up with the engineering innovations on the wheels that while the vehicle is moving, the wheels can be, the suspensions can be changing to adapt to the current topography. So this project was my first attempt at autopilot control of vehicle system. So this is my airborne drone. The funding partly came from the Nigerian Commissions for Communication. So it's meant to collect sensor data on the farm and send them via a secure or internet radio communication to database to enhance agriculture in the tropics. So it is an attempt by me and my team to take automation to the sky. So this is all I've been doing in the last 5 to 7 years as a scientist and someone who loves technology. So before I end this, presentation, I would like to show some of my references that are related to the presentation. So this is where you find my internet vehicle, the published paper in Elsevier. Then this is my YouTube channel, where I have been posting and publishing my various technical demonstrations in the last 5 years. So I will just go to the internet and play one of those videos. So these are all my development in the last 5 years. So I will just play one of them so that people can have an overview of what I used to do.
Okay.
So thank you very much for listening, and thanks for the audience. And I hope we have better opportunities to collaborate and develop more exciting things in this area of science and technology.